Okay, question 15 done. Now looking at question 16. Okay, so question 16. Question 16, first one in the new year. Let's have a look. Okay, so it says 2 plus x to the power 5 plus 2 minus x to the power 5 is equal to something that is a plus bx squared plus cx to the 4. And they want you to find the values of a, b, c. Okay then. So let's take a Pascal triangle, okay, and go 1, 1, 1, 1, 2, 1. So that's x squared, that's a quadratic level to the power 2. Okay, 1, 3, 3, 1, that's to the power 3. 1, 4, 6, 4, 1, that's to the power 4. 1, 5, 10, 10, 5, 1, that's to the power 5. That's what we want. So all of our NCRs will be with those numbers. Okay, NCR 0 will be 1, NCR 1 will be 5, etc. Okay, and so now we can do this, and we can say 2 plus x to the 5 is equal to, and it's going to be 1 times 2 to the power 5 x to the power 0, and then this one is going to be 5 times 2 to the power 4 times x to the power 1, and then we're going to have 10 times 2 to the power 3 x squared, and then it's going to be 10 2 to the power 4 x to the power 3, and then it's going to be, no, that was wrong, that one should be 10 squared, going up, going down, and then not 10 but 5, just following the Pascal triangle. 5 2 to the power 1 x to the 4, and 1 times 2 to the power 0 x to the power 5. Okay, and then 2 minus x to the power 5 is actually going to be equal to all of that but instead of us using a 2, the only difference, why is that all got itself in a tiz was? A moment. Okay, that was weird. Okay, so the only difference is that should be written like that. Is that instead of a 2, is going to be a minus 2, and the reason I'm changing that cubic there is because I want the minus 2 inside the bracket as we work this out. Okay, so this one gives me 2 to the power 5, which should be 2 to the power 5, 32. 2 to the power 4 is 16 times 5 is 80, so 80x. Okay, 2 to the power 3 is 8 times 10 is 80, 80x squared. 2 to the power 2 is 4, 40x cubed. 2 times 10, 2 times 5 is 10, x to the 4, and 1 times 1 times x to the 5. Okay, now when we come over here, we get very similar results, but of course, because it's a minus 2, we would get minus 2 to the power of 5 is minus 32. Okay. Yeah. And then we would get a minus 2 minus 2. That's a positive, so that's an 80x. Okay. Let's just double check that one. 2 times 2 times 2 times 2. If they're all minus 2's, those two give me 4. Those two give me 4 minus 2. So that gives me minus 8, which gives me minus 32. Okay, minus 32, 4. This one gives me the minus 80x squared. This one gives me the 40x cubed minus 10x to the 4 and x to the 5. Okay, now as you come across, we're doing this one, add this one. Okay, so we end up with 0 plus 160x. That becomes 0 plus 80x cubed. That becomes 0 again, and 2x to the 4, to the 5, sorry. You'll probably hear the hesitation in my voice as I'm doing this, okay, because I'm looking at it going, it's not coming out as the same or the correct coefficients, and after having a quick look at it, trying to decide what's wrong, I've written out the question wrong. This is 2 minus x. It's not minus 2's down here. Okay, they are all positive 2's. Okay, so they were all correct. It's minus x's. So that has a difference in the fact that it changes that into a plus, and that into a minus, plus, minus, plus, minus. Okay, which then has the completely different effect when you add it all up. Okay, so as always with all of these things, when the mistake starts to appear, you can start looking at it going, that doesn't feel right, what has happened? Go back, check your working. So 32 and 32 is 64. That's better because that gives me my a value. Then my x values cancel. Then I get 160 x squared from the 80x squared and 80x squared. The x cubes cancel. I get 20 x to the 4 and the x to the 5's cancel, giving me a equals 64, b equals 160, and c equals 20. Okay, next bit, using the substitution of y equals x squared. So that was part A. Part B, so using the substitution of y equals x squared, and your answer to part A, solve this problem. Okay, so for that I'm going to look at it and I'm going to say, well, I'm going to start with the fact that I can put it in and I can say that x, I can say that 64 64 plus 160x squared plus 20. Now I'm going to write that out as x squared, because x squared times x squared is x to the 4, is equal to 349. And so now we are going to use the substitution to put in 64 plus 160y plus 20y squared minus 349 equals 0. Okay, so 64 minus 349 minus 285. 85 plus 160y plus 20y squared is equal to 0. Okay, putting that into a polynomial solver on the calculator. Okay, 2 degrees on there. So 20 for the coefficient of y squared, 160 for the coefficient of y, and minus 285 for the standard thing, and it tells me that y is equal to 3 over 2 and minus 19 over 2. And since x squared is equal to y, I can now say that x squared is equal to 3 over 2 and x squared is equal to minus 19 over 2. So I'm looking at x being equal to the square root of 3 over 2, and this gets a bit awkward. X equals the square root of minus 19 over 2. Since this is unreal and into the world of imaginary numbers, square root of minus numbers gets very awkward. Don't forget that we should have a plus minus on all of these. Okay, and that's question 16 done. On to question 17. So, question 17 is saying that in the binomial expansion, 2 plus px to the power 5 has a coefficient of 135 for x to the power 3. So just coming up here to a binomial expansion, not a binomial expansion, but a Pascal triangle for powers of 5, we have 1, 5, 10, 10, 5, 1. And the x cubed on that, you can see there, is the 10 from the triangle. So what we can say is that 10 times 2 to the power, just looking at the x cubed value here again, so it's 2 to the power 2 and x to the power 3. 2 to the power 2, and then the x value, px, to the power 3 is going to be equal to 135x cubed. Let's see if we can solve for p on that. So that's going to be 2 times 2 is 4, times 10 is 20. So we've got 20 p cubed x, what am I talking about? 20 is 40. X cubed is equal to 135x cubed. The x cubes cancel, so we're left with 40p cubed equals 135. Okay, p is equal to the cube root of 135 divided by 40. Okay, 135 divided by 40 is 27 over 8. cubed root 27 over 8, and the cubed root of that is 3 over 2. Okay, the value of, and then they want us to find the value of the coefficient of x to the power 4. So x to the power 4, coming from that binomial of, not binomial, but Pascal of 1, 10, 10, 5, 1. We've just had that one for the x cubed number, so this is the x to the 4 number. So we are going to have 5 times 2 to the power 1, because it drops a power, times 3 over 2 for the p value, x to the power 4 is going to be 5 times 2 is 10, times 3 fours, not 3 fours, but 3 to the power 4 is 81 over 2 to the power 4, 16, x to the power 4, okay, so 81 divided by 16 multiplied by 10 is 405 over 8, x to the 4, giving us a coefficient of just the 405. Over 8. Okay. Which, if you check in the back of the book, they want the answer of 50.625. It's the same thing. Okay. Okay, last one for this video then. Question 18. Find the constant term. Find the constant term in the expression of x squared over 2 minus 2 over x to the power 9. So the constant term is anything that's only got a, what would be x to the power 0, so no x value to it. So looking at that, it's going to be, I think we might need to multiply it all out and see where it all comes out to see which one it is, because I fear that it's going to combine with both of these. So the Pascal triangle, we know from the last two questions there, we can easily work it out, is 1, 5, 10, 10, 5, 1, and that's when we're x to the power 5. So when we're x to the power 6, x to the power 7, x to the power 8, and x to the power 9, we want to do 1, 6, 15, 20, 15, 6, 1, 1, 7, 21, 35, 35, 21, 7, 1, 1, 8, 28, what's that one, 35 and 21, 56, 56, 70, then it repeats itself going backwards, okay, and then when we get down here, 1, 9, what's that, 36, 56 and 28, do I have to calculate to make sure I make no mistakes as I'm so good at, 84, 56 and 70, 126, okay. So, working this out very swiftly on this one then, we're going to have 1, 9, 36, 84, 126, 126, 84, 36, 9, and 1. Okay, and that's going to be multiplying x to the power x squared over 2 to the power 9, and then it's going to be taking x squared, why can't I select that? Not pasting for me. Okay, so to save time on the video, I have just copied and pasted my x squared over 2, and it needs to be to the power 9 on that first term, but to the power of 8, 7, 6, 5, 4, 3, 2, 1, and 0 on the last term, and then on this one it's going to be the minus 2 over x. Okay, then I'm going to do the same, copy and paste it down, but these run in the opposite order, 0, 1, 2, 9. Okay. Okay, so putting this in, then we should get this one to the power of 0, to the power 1, 2, 3, 4, 5, 6, 7. Why am I missing one? 0, 1, 2, 3, 4, because I've only got one there, don't I? Okay, let's correct that. Okay, that's a bit better. I've squeezed an extra 1 in there, I just missed it because my handwriting's so bad. So to the power of 3, 4, 5, 6, 7, 8, 9. So now as we start multiplying these out, okay, that's 1. Anything to the power of 0 is 1. So x squared to the power of 0 to the power of 9 is 2 times 9 is 18. So we get x to the 18 over 2 to the power of 9, 2 to the power of 9, 512. Okay. With this one, you get 9x to the 16 over 2 to the power 8, which is 256, and that needs to be multiplied by minus 2 over x, which will cancel an x with an x16, giving us an x to the 15, not one of the terms we need. Okay, and as we start working this through, we're going to come down and get to one of these that has that cancels out. Okay, so this one here is going to be 36 over x to the 14, x to the 14 over 2 to the power 7, which is 128, and that's going to be multiplying by a positive, in this case 4 over x squared. So that becomes an x to the 12. That's not one we want. Okay, coming down on the next one, 84 times x to the power 12 over 64 times 8x cubed, that'll be a minus. Okay, and so again, as we cancel there, that becomes x to the 9, not the one we want. Okay, 126 x to the 10 over 32 times a positive 16 x to the 4 gets us x to the 6. That's close to the constant, but not quite there. X to the 6, I mean, it's closer than x to the 18. Okay, next one then is going to be 126 again, but x to the 8. Okay, and 16 times by a minus, that was a 16, so it's a 32 this time. And x to the 2, 3, 4, x to the 5. Okay, so that's there. Let's do a couple of lines in here so that we are equaled up and we know which one we are working on, because I fear that I just didn't leave myself enough space as I was working this all out. Okay. Yes, didn't think I had enough space there, and it was starting to get very messy. Okay, but that maybe doesn't simplify it, but it keeps it slightly neater. Okay, so where are we at then? 126. So 84 x to the power 6 over 8 times by a positive 64 x to the 6. Now there, when we multiply those two terms, we're going to end up with a constant on it. Okay, so that one we like a lot, so we'll just give it a little mark. Let's check the next one, because I suspect that we're not going to be into a constant. We'll be to a power of x of some description on it. So we will have 36 times x to the power 4 over 4 times by 128 over x to the 7. And so yes, we'll be like x to the minus 3 or something. So that's no good. So let's have a look at what this one above us comes out as. Okay, so as we multiply that out, we get 84 times 64. 84 times 64, which is 5,376. 5,376 over 8 divided by 8, 672. Okay. So 672 is the constant term on that binomial expansion, which started off as x squared over 2 minus 2 over x to the power of 9. Okay.